So hello everyone and welcome back. In our previous video, we have learned how earthquake originates from the focus and strike the epicenter. Today, we are going to look closely at the actual energy messengers that causes all these shaking seismic waves. We will break down exactly how these waves travel through the earth, why some are fast, why some only travel through solid ground, and how to differentiate between primary and secondary waves in the easiest way possible. Let's get started. So first of all, we will see the classification of seismic waves. First we see the classification of seismic waves, the surface versus interior. So point to the top diagram showing focus and epicenter. So first let's understand what when an earthquake occurs to a focus energy travel out in the form of waves. These are broadly classified into two categories. First one is body waves. So first one, body wave. These waves travel through the deep interior. This body wave is travel into deep interior, okay, of the earth. This includes P waves. This includes P waves that call primary waves and S waves which call secondary waves. So secondary waves is what? That one is surface waves. Now we see the surface waves. Once this body waves hit the surface at the epicenter, they interact with surface rocks and create new waves called surface wave, also known as Rayleigh and Love waves. These are the ones responsible for all the visible destructions on the surfaces. So what we see in primary waves? We will see P waves. First we see the P waves. This one. So P waves we will see. Point to the P and S box diagram. We will see the horizontal arrows. We are seeing this. Now let's look at the first type of body wave, the primary wave, which called P wave. So movement in P waves, the particle motion is parallel. As we see, particle motions is parallel to the direction of the wave proportional. The propagation we will see here, it moves like a spring, pushing and pulling, causing compression and expansion in the rocks. Okay. So speed, what is the speed? So these are the fastest seismic waves traveling at high speed of 7 to 8 km per second. 7 to 8 km per second. Because they are fastest, they reach from the focus to the epicenter first. Very first they will reach there. So in medium, what we will see? P waves can travel through all mediums, but their speed varies solid, liquid, gas. Fastest in solid, very fastest in solid. Slowest in gas. So gas में slow. So now we will see nature. Because they compress and push forward, they behave just like sound waves or pressure waves. Their nature was also sound wave like also and pressure wave like also, both. And they also have a longitudinal wave like nature also. So secondary wave. Now we see the secondary wave. So we see in a secondary wave which called S wave also. So in S wave diagram, we vertical arrows. You see here vertical arrows. So what is the movement? Unlike P waves, the particle motion here is perpendicular. This type. Perpendicular at 90-degree angle to the direction the wave is moving. As we can see in the diagram, while the wave goes forward, the particle move up and down. Okay. So speed and arrival. What is speed and arrival? Their speed is slower than P waves, which is why they arrive second at the surface. So medium restriction is very important. So what is the medium of their travel? So you will see here, as waves can only travel through a solid medium, they completely disappear or fail to travel through liquids. This property is exactly how scientists discovered that the Earth's outer core is liquid. So what is the nature? Now we see the nature of this secondary waves. Because of their up and down crest and through motion, they behave exactly like water ripples or light waves. Water ripple and light waves. So therefore, they are classified as transverse waves. So now we will came in last part, that is to quick summarize if you want. P waves are fast longitudinal waves that rush ahead through solid, liquid and gas alike, pushing like sound waves. So and S waves follow the second, moving up and down like a transverse wave, but they only travel through solid together when they trigger surface wave, Rayleigh and Love wave. That's when we experience major earthquake tremors. So, I hope this comparison makes seismic waves crystal clear for your exams and conceptions. If you enjoyed this video, please like, share and subscribe to the channel. Let me know in the comment which wave behavior surprised you most. Thanks for watching and I will see you in the next geography lecture. Thank you so much.